Hello, statistics students. Here's a video on section 8.4, comparing proportions from two populations. This is where we're going to work out the introduction example. So in section 8.4, the first video, we introduced this example for stem cell research. Consider as an example the opinion polls on embryonic stem cell research introduced in section 7.5. This medical research shows great promise in the treatment of several major diseases, but is controversial because it goes against many people's religious convictions. The Pew Forum on Religion and Public Life has, over time, conducted surveys to assess Americans' support for stem cell research. In 2002, 43% of Americans expressed support for stem cell research. Later, in 2009, it increased to 58% who supported this research. Can we conclude that support has changed in the population of all Americans? Or could this difference be due to chance variation during the sampling procedure? So this is a two population hypothesis test. The first population consists of all the Americans in 2009, and the second population consists of all the Americans in 2002. And so our population parameters will be defined accordingly. So population proportion 1 is the true proportion of Americans in 2009 who support stem cell research, and the population proportion 2 is the true proportion of Americans in 2002 who support stem cell research. Then our hypotheses. We want to see if we can conclude that support has changed in the population of all Americans. So our null hypothesis will be no, it hasn't changed. So the population proportions of Americans who support stem cell research in 2009 will be the same as that in 2002, because there's been no change. And so we would write that in symbols as P1 is equal to P2, or P1 minus P2 is 0. Now the alternative is what we're trying to see, or trying to show, or can conclude. And so that is if it's been changed. So the alternative is the population proportions of Americans who support stem cell research is the same. Sorry, alternative is that they are different. So the alternative is that the population proportions of Americans who support stem cell research is not the same in 2002 and 2009. And the null is that the population's proportions are the same. So the alternative would be stated as P1 does not equal P2, or that P1 minus P2 is not equal to 0. In this introductory example, we don't know the sample sizes, so we don't have all of the information to do this on our own, but the results were as follows. The z-test statistic, which is P1 hat minus P2 hat, came out to be 8. Sorry, that's the sample proportion P hat, and then the test statistic came out to be 8.22. Now, you should not need to do any checking to find the p-value to this, because we know that the empirical rule states that nearly 99% of the data lies between 3 standard deviations from the mean, and we're 8 standard errors away from the mean there. So that's really far, which means that our p-value is going to be very small, and we'll just say that it's 0. Therefore, our conclusion is that the change was not due to chance, and that there was a real shift in support over this time. So we have sufficient evidence to conclude that the population proportions of Americans who support stem cell research is not the same in 2002 and 2009. And this concludes this video on the introduction example for section 8.4, comparing proportions from two populations.